So how would you consider it? You're dead right, but how would you consider it?
Maybe based on like cost that those people would go on those people.
Yes.
Isn't this not an economic question? Isn't this a social, moral, environmental justice question?
You
should. Like, should you? Well, I mean, even if you're going to make a lot of money, should you? Like, isn't this not an economic question?
What's not an economic question? I'm dead serious, by the way. I'm not teasing. What's not an economic question? You see, even if you want to impose value judgments, we talked about value judgment, you're using the phrase moral judgment. Make it a moral judgment. But why wouldn't you still want to know the economics before you impose a moral judgment?
Because you already know the world and you don't need to know.
Well, what would be the morals in this instance? What would be?
Okay, because these people. Okay, so he's saying people might object. People who live in the refinery might object. You were mentioning Richmond, kind of mocking it. It's not very affluent. Environmental justice-wise, they're probably not going to get the community action required to stop the refinery. I'm a white policy major. I'll probably be able to implement it. ESPN classes galore. But
ESPN classes? Yeah. I think that's society and the environment. I don't think it's ESPN, but go ahead.
It's one of those classes. But
Yeah.
I just don't see how you can try and put monetary value on that. On how much those people's lives are worth to me as a policymaker looking in on someone else's life.
Looking in on someone else's life.
This isn't going to go next to my vote. This is going to go next to the people who don't have the money or power to fight back.
Mm-hmm.
And you're asking, should, so wouldn't this not be based on whether the money turns out that I'm going to make money from this, or the city's going to make money?
Well, all I'm trying to do is illustrate that just looking at these three criteria is not enough, regardless of whether you want to impose moral judgments or not. But let's take the moral judgment. Let's suppose you make the moral judgment that no one should be worse off. That is to say, coming back to your statement, I'll look at what are the consequences for people that are located near the refinery. Now, I can go a step beyond that. Is there enough in the way of benefits to increased employment, increased output, increased property taxes? Is there enough to tax that as a basis for compensating those located close to the refinery, either in assisting them to move away from the refinery, and or if they want to stay there, give them sufficient compensation so they're at least as well off as they would have been without the refinery? Now, there's no moral judgment there. There's just what's referred to as a Pareto outcome. Namely, I want to make sure that no one's worse off. It's not just looking at the aggregate benefits and costs, but I'm only going to make this decision so long as, coming back to your phrase, environmental justice, my environmental justice is very simple. No one can be worse off. And how do I measure whether they're worse off? The economic answer is I'm going to value what is the consequences of the entire community and what are the economic consequences for those people that are located close to the refinery. So, I mean, there's a way of integrating the economics with value judgments, with environmental justice. Just to come along and say, environmental justice prohibits us from doing anything because we're going to make those people close to the toxic waste site or those people close to the refining facilities or those people who are close to a landfill, they're going to be worse off, so we should do nothing. That doesn't serve economic growth. Okay, so the answer. It turns out that Cameron's dead right. You should consider the distributional consequences, and those people located near the refinery are going to be those that disproportionately suffer as a result of that refining activity being located close by to their homes. Okay, the actual screening, in effect, no one should go down the line of evaluating things like environmental justice if the project can't even pass a benefit cost criteria. Because if it can't pass that criteria, there's no need to go any further, because there's no basis for generating enough in the way of growth or enough in the way of the economic pie that can be redistributed to serve everyone's interest. And as we see in environmental impact statements, that's what the EIS refers to here, there are all sorts of manipulations that have been documented about environmental impact statements. And you can do the same thing with regard to benefits and costs, because a lot of the potential benefits, not so much on the cost side, but certainly on the benefit side, a lot of that's intangible. So how do I go about getting a concrete, defensible evidence that goes to those potential intangible values? And there's great controversy within the general public about whether benefit cost criteria should be used at all, with the argument that, coming back to the underlying legislation, that the polluter should pay regardless of what the cosine consequences might be from a particular environmental project. Here in the state of California, as a result of legislation, we are required, as different cities or different public officials, to perform benefit cost analysis. That's what BCA is here. It's a requirement that is legislatively determined as part of our democratic process. And to make the argument, and here's my value judgment, to make the argument that you shouldn't do that because of environmental justice, first of all, you'd be violating what is the democratic consensus here in the state of California, and you'll also be violating another basic fact. Those benefit cost analyses that are required have led to the most stringent environmental regulations throughout the United States, here in California. So it's had a positive effect on the kind of environmental laws that have been instituted here in the state of California. Okay, one last methodology that's out there is cost-effectiveness analysis, and we've touched on this in the past, and whenever there is a problem with regard to quantifying the benefits, maybe there's so many intangibles, but yet the public sector or the democratic process has come to the conclusion that this is a project that is going to be done. It should be done. And once that decision is made, then the methodology we should be using is to minimize the cost of achieving or implementing that project. Just like when the government or the EPA comes along and recognizes what environmental health hazards might exist, and they set targets, MCLs, for contaminant levels. Now, the burden of the economist is to minimize the cost of achieving that target. And that's what cost-effective analysis is all about. So there's some predetermined objective or target, and what we want to do is find that outcome and implement that outcome at the minimum cost. Okay, let's turn to today's lectures. By the way, is there any questions on the various criteria? To summarize, there are 4 criteria, right? Because I've added a 4th one, namely the cost effectiveness. Given that I don't know what benefits are, but I've got a target that I want to achieve, then the 4th methodology is to minimize cost of achieving that target. Charlie? No. Clearly, from the standpoint of basic concepts, you should take into account the complete horizon. So if you're investing, say, in a refinery or permitting a refining plant, you're looking at that either in perpetuity or you give them a 50-year entitlement, whatever entitlement they're asking for that you're evaluating. If they're asking for a specific length of time, you should evaluate the benefits and costs over that full horizon. Yeah, exactly. Okay. Now, we want to turn to looking at waste. And just like pollution, some of us object to this, but in every society throughout the world, there is an optimal level of waste. I know that's hard to believe, but there is, from the standpoint of economic incentives, the optimal level of waste is not zero. And if you stop and think about the Coase theorem for a moment, it should be intuitively clear to you that you couldn't satisfy the Coase theorem either if there are large transaction costs or no transaction costs, and come to the conclusion that it's in society's best interest to set waste at zero. Okay, given that it's not given or even a value judgment, but it should be zero, how do we go about determining the efficient level in waste and or pollution? What policies are out there that can lead to the right incentives that will lead to that efficient level? What are the pros and cons of two major policy instruments that we've talked about a number of times in lecture already and in your readings? One is corrective taxes, or here I defined this as emission charges because that's how your reading for today defines it, or introducing tradable emission permits. Now, let's look at your textbook reading for today, and here we're going to look at the graph that they talk about in terms of inputs that result in some environmental damages. And the environmental damages are represented at the bottom of this chart, namely environmental damages that cause harm to individual citizens or damages to the ecosystem, to trees, lakes, buildings. Those are the environmental damages. Where do those environmental damages emerge? And we're looking at two economic activities. Here, farming row crops, concentrated livestock. This has some similarity to the case study that we took out of Coase's article, The Problem of Social Cost. Remember, the cattle raiser versus the crop producer. But what we have here is there are emissions or waste that's generated by combining inputs into some production process that results in some output. We can control the potential environmental harm in the use of those inputs in the production process. We can clean and provide abatement procedures along the way, but even though we do, there's still going to be generated some emissions. Likewise, in concentrated livestock operations, once again, we have inputs that are combined through some production process, which we can manage to abate any possible emissions, but there's still emissions that emerge, and then there's some output quantity, and all of these emissions have some effect on ambient quality, whether that be ambient water quality, or ambient air quality, or ambient land quality. And the exposure to that ambient quality results in the environmental damages downstream. So these are quite clearly a number of points at which the public sector could be involved if there are no prices set on the emissions, and the only incentives that exist for private firms that are making choices about the amount of production of row crops or the amount of production of livestock, if they do not bear any of the external cost, then we're going to have more emissions and more degradation of environmental quality in the three major resources that I suggested, air, land, and water. Then the question becomes, how can we intervene as a public sector to change those incentives? Well, we can intervene here at the input level. We can have different input standards that are imposed legally on those production processes. We can impose different standards with regard to what sort of emissions are allowable here and here. And a third possible public sector policy would be to set technologies, the kind of technologies that must be used in each of these kinds of production processes. Those are the three critical points where the policy or public sector has intervened historically and continues to intervene here. For example, if we come back to concentrated livestock, one of the emissions is waste, animal waste. And for many years in this country, animal waste was dealt with very simply, land disposal. And some people colored the land disposal with the following argument. This is an organic fertilizer. Gee whiz, why should society be concerned about distributing an organic fertilizer on land or land throughout some watershed, particularly if it's my land and I have a property right on that land? Well, it turns out that waste, if it accumulates, it contains a lot of phosphorus. Phosphorus migrates through soils, finds itself at groundwater and or to watersheds, to rivers and lakes, and phosphorus that isn't completely assimilated, which it is generally not, ends up having degradation effects on fish, wildlife, and the quality of lakes and rivers. So that's the kind of thing that we're talking about. Now, with regard to the different types of pollution, it's important to keep in mind that there's a lot of complexity out there. It's very easy to talk about, well, there's pollution and we want to reduce and or determine the optimal amount of pollution by providing the right incentives to control or abate what would otherwise be the emissions that take place. But in doing so, there are a number of important measurements that have to be conducted. One is, what is the absorptive capacity of, say, the air, water, or land? An example, a lot of chemicals have a very short half-life. So if they are in groundwater, for example, and you completely dilute those chemicals over time, they will be dissipated and have no adverse long-term consequences. But that's a scientific issue, right, that has to be determined. But the absorptive capacity is a very important, the assimilation capacity, if you will, that has to be set out before we determine how harmful in the long term a particular pollutant might be. Now, there's a further decomposition with regard to stock pollutants versus flow pollutants. And stock pollutants are ones like heavy metals, recyclable materials. They're non-recyclable. The environment generally can't absorb stock pollutants. So that's a serious problem. Fun pollutants are ones for which the environment has some capacity to absorb and to dilute and ultimately, at the end of the day, assimilate with no adverse consequences. There's a further distinction that should be drawn between local pollutants, which generally cause damages near the source of wherever the emissions take place, versus regional pollutants that cause damage over greater distances. And you can extend this to global pollutants, which clearly takes us into issues about global warming, climate change, with regard to those types of pollutants, namely greenhouse gases in particular. Now, the prior slide really goes to the physical flows, right? But we want, in terms of benefit cost analysis, we want to put some value on those flows. We're never going to be able to get to an optimal amount of pollution unless we can determine what the value is of those physical flows, or the negative value, if you wish. And this takes us into a measurement of the environmental damages. one measurement is a horizontal dimension of damages, and this goes to local versus regional pollutant damages. There's a vertical dimension of the damage that goes from the ground level up to the upper atmosphere, what damages take place there. Surface pollutants, water pollution, which cause some damage near the Earth's surface, whether in land or water. Global pollutants that I already measured is another decomposition that we have to worry about. And all of these different pollutants have a different dynamic process that has to be measured if you're going to be able to do a concrete benefit cost analysis. Okay. Now, there is a figure in your textbook reading today that goes to the amount of nitrates that have been measured throughout the United States, and this is a graph that's presented in your textbook reading for today that gives probabilistic estimates with regard to the nitrate levels in groundwater throughout the country. And if you look at the various, the darker areas, this is the highest nitrate levels, which is of concern, particularly if those surrounding communities are accessing that groundwater for drinking water, right? So when you look at this map, you say, gee whiz, this is the current measure of that pollutant, that contamination that exists in groundwater. And when you look at this and say, okay, right away, I look at these dark areas, I'm concerned about that. That's a physical measure of the pollutant. But how concerned I am has to be related to the nature of that pollutant, how the resource medium in which it resides is used by the population in surrounding areas. So even though, and it turns out in the Midwest, given the amount of fertilizer that they use and the nitrogen content, it shouldn't surprise you that the higher concentration levels are located in those particular land areas. Yes, you mean the areas that are, yeah. What's important here is the fact that when you look at this, this is a physical measure of your concern. But with regard to the damages, that's a much different analysis, right? If there are high concentration levels in North Dakota and there's nobody living there, it's not a big issue because ultimately it's not going to result in health risk or health hazards. While if it's surrounding the city of Chicago, it's a much different question. And it's important to keep in mind both the physical flows and what the consequences might be with regard to the ultimate damages as we outlined in that first figure, 12.1. All right. It's also important to keep in mind with regard to what is the optimal level of waste or the optimal level of pollution, to keep in mind what can either human resource or a natural resource, what can it tolerate with regard to a given level of a pollutant. Arsenic, for example, if you have too much arsenic, you're dead, right? If you have very small amounts, and all of us, if there's a test done of our blood levels, there is small background level, hopefully just background levels of arsenic. And if there's more than background level, whoever you're eating with, stop eating with them. But nevertheless, lead, for example, if you look at lead-based paint, which is now prohibited, has been prohibited for environmental reasons in the United States since 1978. Up to that point in time, particularly young children that are undernourished found chewing lead-based paint an attractive activity. And it turns out that the lead, as it goes up in your blood level, it gets to certain levels, it's very harmful. In particular, it has a direct causal connection with intelligence, with brain power. And the associations between lead-based paint and performance of young children in K through 12 has been well documented. And that was the basis for eliminating lead-based paint. But that doesn't eliminate all lead in economic activities here in the U.S. or the rest of the world. But what is important to recognize is that certain levels are tolerable where other levels are unacceptable. And that will influence, depending on what those relationships are, will influence what is ultimately in society's best interest with regard to the amount of such pollutants. Okay? At the end of the day, taking into account the actual quantification of the benefits and all the costs, once we've got that, then our basic principles that we discussed in the first lecture can be used to determine the optimal level of pollution or the optimal level of waste. And this requires equating the marginal benefit with the marginal cost of controlling pollution. And as we've noted in your problem set for today, the marginal benefit is nothing more than avoiding the marginal damage of pollution. Right? So if there's a certain amount of pollution out there and I can reduce it by 50%, the improvement in the health risk or the improvement in the environment is measured by the amount of reduction in those damages.